All right. Hello and welcome everyone to the data engineering session on how do we build next-gen applications on a unified data platform. So that's me, AMARJEET. I'm a solutions architect with Gather team. So what we're going to cover in this session today, how do we transform raw data into valuable outcomes? And after that, what are the key challenges and solutions while we are solving this data integration problem, and how Gather can help you. And we'll see it in action. So the first thing, transforming data into valuable outcomes. So businesses have a lot of data, organizations have a lot of data, and they want to generate outcomes or insights out with that. Seems pretty simple that we just want to capture, clean, convert, and consume, and repeat the process. But any use case starts with evolution, where you want to analyze the data at scale, you want to infuse AI and ML, you want to generate actionable insights, and while you're doing all that, it should have low time to market, and everything is affordable. So that's about while you're building a use case. What happens next? So once you are successful, you build one, then comes sustenance. Because you have to maintain that. You have to make sure that the solution which was built is always available and it's always up to date. So insights are real and are up to date. Businesses are changing, so the new changes that are coming in, you should be able to adapt to that. Since the solution worked for one problem, it should be reusable to solve similar such problems. And finally, there should be zero maintenance ideally. So you started with evolution, you build the use case, and you maintain sustenance. That's how we reach from data to valuable outcomes. Now, how do we actually achieve it? A good data integration solution will help you do that. What are the key challenges which a good data integration solution should address? So the very first thing, your journey starts that it should operate at scale and should allow you to have a multi-source ingestion and should cater to real-time and batch use cases. So it has to be an all-in-one data ingestion platform. Because newer techs are coming in every 6 months, you don't want to miss out on opportunity on leveraging that. So all-in-one data platform will help you leverage that. Let's say you are able to read data from anywhere. You would like to experiment same with the targets so that you can write anywhere. A lake house, a warehouse, a relational database, a file store, a CRM system, so that you identify what works best for a given use case and you have a flexibility to choose the right solution. And you want to encourage the culture of exploration in your team. How do you do that? You have the feature of exploring multiple targets. Then you should not be limited by a tool that does only EL, extraction and load, or ELT, or ETL, or ETLT. The solution should be able to do everything, and it should be extensible to solve multiple problems and add on new features. Now Gen AI comes in. Earlier it was tricky to process unstructured data, but now everybody wants to process unstructured data. Chat conversation, summarize it, give me what exactly happened in this chat. Extract entities from resume, extract entities from context, right? Tell me everything and process every bit of unstructured data we can find. And don't forget the traditional ML. So you should be able to do both, right? It's keep on piling up. More and more features are required to have a data integration solution which an enterprise can rely upon, right? You have ETL, you have machine learning, they got to talk to one another. You can't have them working in silos. And everything should be backed by a CI/CD pipeline. It should be reusable. It should be standardized. It should establish developer discipline. What do we mean by that? So think of it this way. You solved a problem once, right? But you make it reusable so that 100 other developers, if they're trying to build the same pipeline, they use exactly the same pipeline. They don't have to rebuild it. It should be reusable, right? So that you fix it at one place and everybody else's work got fixed automatically. So you standardize and you establish developer discipline. maximize your team's effectiveness, make them efficient, make them effective. See, they're not just building ETL pipelines, they're creating assets which will eventually be consumed by data consumers. So don't think of them as ETL creators, think of them as data assets creator, right? Because data assets bring traceability. And finally, it's a next-gen application, so it should have a dashboard where you can actually act upon. So you started with data at scale, you went through all these steps, and finally you have business outcomes. So the idea is, all these things are required to have a valid data integration solution so that it addresses the key challenges. And these are the building blocks of it. Let's see an architectural setup. So you're reading from data sources, NoSQL, RDBMS, distributed videos, tweets, AWS, emails, etc., right? A variety of sources. Real-time batch data, but while doing that, you got to have a visibility. How much data got ingested? How much data actually reached the target? Are there any errors? So visibility is important. Then you're persisting it in a transient layer. Why are we doing that? Because we are trying to build a ELT solution. Now there are multiple ways in which you can actually transform. Maybe you are transforming through a complex process orchestration. We'll see that in a minute. You're transforming using structured data storage right there in your pipelines where you're writing ETL rules. Or you're applying data quality checks, which are defined by your data stewards. And finally, you're persisting at a target location of your choice, right? But does it end here? No, it doesn't. You have to provision so that users can consume it through APIs, through file stores, through mobile devices. And of course, it has to be integrated with AI and ML. Yeah, it's a long journey. And finally, the data has to be accessible by all these users so that they can generate insights on top of it. And don't forget, it has to be backed by all these capabilities, which are making it sustainable. So your builds should be automated through CI/CD tools. Disaster recovery should be in place so that you don't lose the business. It should be cost effective. Security should be a cornerstone. You should be able to certify your data, and at any point in time you should have matrices telling you where your data lies. Gather, a solution offering, sits in the center of all these solutions that we established in earlier slides. So it encourages the culture of exploration. It enables you to create your own data asset. It provides integration with generative AI and scalable ML. Enables cross-functional collaboration between your data scientists, data analysts, data engineers. It's an all-in-one data ingestion platform. It's self-service, low-code, so that anybody can operate, establishing blueprints and generating business, creating business automation. Let's see that in action. Now, how do we realize EL, ELT, or ETLT? Let's have a look at that. So what you're seeing is a gather canvas. This is the place where you drag and drop components from the palette, which is available on the right. You can practically connect from any source, ADLS, and you can write your custom sources. That's how it's extensible. So it's not limited by the set we provided. You can write your own custom components. You choose any source, and then you transform it using a variety of operators. So now we have deduplication, we have data quality, we have data cleansing, aggregation, and a lot more. But you can still write your own business logic in Scala, Python, SQL, or you can write your own custom components, because we understand no matter how many operators we build, you're going to need a place where you can write your business logic the way you like it. And finally, you can practically write anywhere. As I mentioned, warehouse, lakehouse, anywhere. You name it, we'll have it, or you can build a custom component. Now that was about palette. Let's see what we are trying to do here in this use case. So let's say you want to build a simple real-time pipeline. I'm reading data from Kafka and trying to write my roster data in S3. So first thing I'll do is, I'll just drag a Kafka component. I'll specify the topic, which is roster feed here, the number of partitions, that is 10, and I want to read the earliest offset because I want to process the full load. You see a glimpse of your data, right? And then you select the S3 operator, you specify the connection, the bucket, the path where you want to write it, and the format you want to write it in. We support text, Avro, Parquet, etc. There are a lot of formats supported. And then you can save it. Either you can append to the existing file or you can override the existing structure. And that's all, that's done. So now when the pipeline runs, it will sync your real-time data to S3. Let's twist it a little bit. Let's say while writing, I would like to partition it by the date. So you can write a small expression that will convert a current date into a year, month, and date format. With that, I'll be using the same key here in the partitioning logic, so everything else remains the same, but you get a partitioning key, and that's all. So in this small pipeline, you're able to load data to S3 or able to load data to S3 in a partition system. So it's very simple, very easy to create these pipelines. Let's extend this idea and let's see how do we transform it. You will notice that it's an XML data. So first thing we'll do is we'll parse the XML data here. I have pulled in the XML parser and the XML got parsed into JSON. And I'm interested in this resource section, which is another JSON. So you're seeing there is a complex nested structure, and now we'll be flattening it out. So that complex structured JSON got converted to table. And we are not writing any code here. And finally, we are cleaning based on a regular expression. It can be a complex logic, and persisting it to RDS. While writing it to a RDS system, we are writing it in a working table. It's in a staging connection, a working table. Why a working table? Because we'll be reconciling it in this procedure. That's reconcile attendance clock in and out, where it will be reconciled with the actual target. So what you're doing is you're doing ETLT. You transformed it in flight and you transformed it after it was loaded to RDS. All that is happening with a simple drag and drop components. So you have the flexibility of realizing any business case here. So with this simple mechanism, let's say you are running this pipeline, and if it is falling short, if it's lagging, if it's not updating data in real time, how do you know? Because when you are building these real-time pipelines, it's very important to know if data is scaled. So for that, we have a feature called lag notification. So if your pipeline is not processing data for any reason, the business users will get an email, they'll get notified through the lag notifications. Now here, email will be sent to gather support. You can have your consumer's email ID here. If data is not synced for 1,000 records, so that's your threshold. So now if you have 1,000 unprocessed record, automatically email will be sent. Whatever we are doing here for streaming pipelines, all can be done for batch pipelines. So that's how you have a platform that solves all these use cases. Let's take another look. Let's talk about the batch use cases, where you are not just reconciling a single table, whereas you want to generate insights on multiple tables. So that's where I have these 5 tables, or pipelines, sorry, which are created here. What I want is, once all 5 are executed, run a query that generates offers based on these 5. So what I can do is I can create a workflow. Now here in this workflow, you will notice that we have those 5 pipelines which we saw earlier. And after execution of it, we'll execute this query. So you're not just executing business logic in a pipeline, but you're able to do it outside the pipeline as well. So with all 5 pipelines, we'll be running this query. That's how you can utilize or build any ingestion use case on Gather. So that's about how do you utilize or build these use cases. Let's have a look at how do we process unstructured data. So the use case we are going to show is one of our customers, they're recruiters, and they have a lot of resumes coming in. What they wanted is, earlier they were feeding the information of the user's email, name, their phone number, their skill set, their responsibilities. They were manually extracting it and feeding it to the system. But with GenAI, it's very simple. Gather provides you to operate those things at a massive scale. Now how does it do that? So here, in this pipeline, what we're doing is, I'm reading this resume data, which is binary PDFs, mind you. You're reading that, and we got the binary data available here in attachments and email column, where you see the size, file name, the binary data. Now you got the binary data. First thing is you want to take that out from this complex nested structure. You flatten it out. Once you have flattened it out, these are available in different columns. You have attachment binary data, you have attachment size, file, etc. What we are interested in is attachments data. I pass it on to PDF parser. It converts this binary data to actual readable text. I'm not splitting it. If you want, you can split it by page, section, words, etc. So you converted the binary data to an actual resume text. And now you have the actual text which was there in resume, which you can feed in an OpenAI extractor. You will notice here that binary data is also there, and we have this resume text coming out. I'll drop the binary data, I'll filter out the empty resumes, and feed the resume column to OpenAI extractor. This is the place where you will provide your OpenAI key, so that it uses your own account for executing these calls. We have this API key available here. We'll test the connection to make sure everything is all right. Now, we provide a bunch of prompts which are available out of the box for sentiment analysis, classification, summarization, entity extraction. So you can achieve all these use cases out of the box, or you can create your own prompt and save it so that you can reuse it. Here, I'm extracting names, emails, skills, phone number, and experience from content using 16K model and 1000 max tokens. Also, while doing that, if OpenAI is not able to generate these fields, not able to extract these fields, we have retry mechanisms where it will retry it multiple times so that it get it right. It's backed by rate control so that it's able to solve the practical use cases. Retry mechanisms are highlighted here. And that's all. So with this OpenAI configuration, now you will be able to extract these key entities from resume text. So you started with a binary data, you converted, you passed it, and you will see the names, emails, and skills available here. So you're able to deal with unstructured data as well. And finally, you can write it to RDS. There is another way in which we are integrating OpenAI. So as I showed that you can write SQL, Python, or expressions in Gather. So we understand that it's a little tricky to write these expressions. So we have built this AI assistant. So you provide input in natural language and it generates the queries or expressions for you. So here I'd like to generate a partitioning key through this AI. So create a column process date by formatting today's date in year, month, and date format. So it come up with this expression. You can use this expression, you can copy this and use it in this section on the left, right? And finally, in fact, you can write many such expressions. So now you don't have to even write expressions. You are talking to the system in natural language. System is generating the code for you and you are using it in the application. And finally, write it to the RDS, and where your data consumers will actually use it for building dashboards. So with that, let's understand what do we mean by building solution blueprints. So the idea is you build a pipeline, now you want to reuse it. So at any pipeline you can go ahead and create template. What template means is the same pipeline will be reused at multiple places. So this is a complex pipeline built in Gather. You can create more complex than this, but the template tells you is you need to tell me what is changing between multiple runs or multiple pipelines. So you tell them that these are my parameters, these will change. Once you specify the things that is changing, that's all you have to do. So next time you want to build this complex pipeline, you don't really have to. All you have to do is go to the template and create an instance of it. Tell us what are the values of those 5 fields or 6 fields which are changing. Just focus on the changes and system will be creating the pipelines automatically. So that you don't have to, right? And then you run them separately as good as you created these pipelines. If there are any changes in any of the pipelines, you just go ahead and change the template. So we built the same pipeline for Snapchat, Meta, Twitter, and Instagram. We did not created it, we just specified the parameters which are changing between the multiple runs. And if I make a change in template, it will be reflected in all of them without me going and changing them. So that's how you are establishing solution blueprints. You're not maintaining these pipelines individually, you are maintaining their code centrally. So that's the idea. So, transforming data engineering with Gather. So you will notice that we are unifying. We're providing a no-code ML-empowered unified UX. You can do any type of ingestion use case, ETL, ETLT, reverse ETL, ML, analytics, ingestion, CDC, process automation. It can cater to any business user, solve any use cases, and finally, can cater to any dimension or domain because it's a data platform. So you're unifying your data consumers, you're unifying your cross-functional teams, the way you solve the problems. Hence, it's a unified data platform. Thank you, that's all I had. Thank you for your time, guys.